So we are so pleased to welcome my wonderful friend and colleague, Dr. TingTing Li from Washington State University. She and I have known each other for a long time, back to our Michigan State days. So you were finishing your PhD there when I was a faculty member there. And we've gotten to know each other very well. She and I have wonderful conversations about AI, and I have sort of an official thing, which is, let's see, you have a disciplinary background in chemistry and K-12. You investigate how teacher students and district people and AI can co-design culturally responsive, linguistically accessible, and contextually adaptive learning environments. Cool. I have to say that we're very lucky to have TingTing here. In my opinion, she is one of the up-and-coming scholars in science education thinking about this work. So we are getting to hear someone who is doing the cutting-edge, ground-level work in this space. So, thank you.
Thank you so much, David, for the very nice introduction. It's so great to be here today to share with you all about my work. I know it's a really challenging time for everyone, especially at the final week. And then, so Friday afternoon, you should be able to get much more kind of fun thing compared to this to experience. Yeah. So for today's talk, I really want to share with you all about my research journey about AI and how AI entered my research work, and then how I have been navigating AI in my own teaching and research. So it's more about reflection, and also more about some questions or problems that I have encountered, and I hope that I can share with you or analyze your suggestions and your advice on something that I'm doing. So before we started, I really want to share with you a set of data that I recently discovered. So this is actually from the one report from the Center for Democracy and Technology. So they did a national survey. They actually find out that 86% of students already use AI sorry for the typing error, in 2024-2025 school year. However, half of them feel less connected to teachers when they use AI, and then so pretty much they use AI without any guidance. That's one thing that really stood out to me. And then for the teacher side, 85% of them report they use AI in their school year, but less than 50% receive training, and then 70% worried about using AI may weaken critical thinking and academic skills. There's some high-level kind of summary. I don't think, what does it mean? So I have something, so I think it's important to realize that AI is entering school faster than its infrastructure can support. And both students and teachers, they face uncertainty. Also, school district overwhelmed by privacy, safety, and policy questions. This is the landscape that I worked in, and I think this is why I'm here today. So then who am I? So this is my background. David gave a little bit kind of the introduction. I came to education field with a chemistry background. I got my bachelor in chemistry, and then started doing chemistry education in my master's degree. And my first dissertation is focuses on curriculum instruction with specialization in science education. Then the second degree is educational psychology and technology. This is my journey. I graduated from Michigan State in 2024, and the same year I got my current position in Washington State University in science education program. So now I'm also co-directing the Center for AI Research and Education. We call it educator. So I really want you to realize that I did not start as an AI researcher. I was trained in science education, educational psychology, technology, and learning sciences. And I started my research work in science teaching and learning. So AI entered my world really because of real classroom problems, challenges I found I was facing at that time. And for now, I'm working with teachers, school district partners, and also industry partners on AI in education projects. So I'm still in the process of learning what AI means for teaching and learning, and then this is a journey I started several years ago. I'm still in the process. But there are two questions, driving questions or central questions that really have been guiding my research work. One is, what role can AI meaningfully play in science teaching and learning? The second is, how might a human-AI collaboration reshape science teaching and learning? Those are the questions that has been guiding my research work, guiding my exploration. So a little bit kind of ago, I shared a little, so how AI entered my work. AI actually entered to my research work, really start from those kind of the models. Some kind of, elementary kids, they're hand-drawn models, or some kind of middle school, high school kids, they're kind of the computer-based models. So I was the person who lead those kind of assessment design and also develop those rubrics and to analyze their model. So some of you who may kind of have the background about science education, for those models, actually it is not just a model, they are their cognitive kind of representations. We want to use their model to really understand, their understanding, their scientific proficiency behind of those models. But this process, analytic process, is very time consuming. So as the person who leads the project, I have to train a group of raters to consistently, reliably to score those student models using the rubric that you just saw. It was a really kind of time-consuming process. So which means I started thinking about AI because of efficiency. I was thinking whether those AI technology can help me to speed up this process, can really help me, and also the other field, the other people. As for instance, if you want to use this model, the student their performance as something to inform your instruction, then you may want to get your student their performance result as soon as possible as instructor, right? And then, but because it takes time, then usually teacher cannot get immediate kind of feedback about student responses, their performance. It usually kind of really lose the potential of formative assessment, the strength. So that's why I think whether there's AI technology can help us to scale the interpretation process without losing meaning. So what I did, so that's my first phase, really using deep learning AI to analyze student scientific models from the efficiency perspective. But, so this is the AI architecture that I built in one of my projects for analyzing the elementary kids, their model. So this is built based upon the convolutional neural network. So we use Resonate 18 as architecture to really kind of, using human labeled data, to train the AI algorithm to identify, to extract the features from student models, and then comprise a feature vector. Then after that, using the feature vector to predict, to classify the new coming data. So if we have a new student model coming in, then we just use the trained algorithm to predict whether, so this student model should be scored as 1, as 2, or as 3. So this is a very supervised machine learning approach. And then I actually got really good result about, from several, projects. But I don't want to kind of just stop at the efficiency perspective. I really want to share. So when I did this work, because that was like at least a 2-year project from several elementary projects, middle school and high school. Recently, I even did an undergraduate level biology kind of the project about using these techniques. But when I did this work, I really feel like, so using AI, a lot of time it can achieve the efficiency goal. If you think about, save time, save money, save effort. So it can potentially help us to provide teachers or instructors feedback in a timely manner. So, but this kind of AI technique, they are mathematical modeling. There is no kind of reasoning behind of that. We had a conversation about that. It's usually strong. It's strong with common visual features, patterns. But if there is, if you have a group of students, their model, you only have very small group of student model. For instance, if you only have 10% of students, their model scored as 2. The algorithm, the machine may not learn from this student model, their feature. So those student model cannot be equally or justly kind of scored or analyzed. especially weak with rare or diverse expression. For instance, students who are English language learners, they usually use very different way to express their idea. But because of insufficient data set that the machine can learn from, so usually the machine just kind of ignore or kind of just ignore those students kind of their responses. But this process may kind of introduce some biases, also kind of reveal some structural inequalities. That's the one thing, that's the first point in 2023. I think this model, this slide show you the kind of one of the way that how students express their idea in a very diverse way. But the model, the algorithm cannot capture those student idea. So usually, especially for those paper pencil hand-drawn model, students usually have a lot of freedom of showing expressing their ideas. But and also from the education perspective, we want to keep this kind of uniqueness. We want to keep this way, the diverse way of expression, because that's one thing that we can see student creativity, their critical thinking, there are a lot kind of stuff thing. Also, it reflects their funds of knowledge a lot. Also for the other part is from the student who are, as I mentioned before, English language learner, multilingual learners. They have different kind of way to talk about their idea, but the machine can often fail to capture this. This is the time, so in 2023, everyone is talking about AI, and then I did that work, and then I started kind of, try to push the field to think about, let's calm down, let's slow down a little bit to really think about whether can we and should we use artificial intelligence for formative assessment in science. That's the first kind of the action that I really want to kind of remind people. When we use AI, AI should be used in a very culturally and linguistically responsive way to teaching and learning beyond just the efficiency that I kind of talked. And also, it's important to kind of remind us to think about it's important to bring teachers in the loop because they know their student very well. So you, as instructor, you know your student, I know my student. So whenever I look at their kind of the responses, I have my own unique interpretation because I know them. So that's the two kind of things I really, I did kind of push the field. I tried to push the field to think a little bit about that. So I actually did some empirical work to see whether that matters or not. And then in one of the research studies, then I bring the teacher into the loop. So for automatic analyzing student scientific models for those elementary hand-drawn models that you can see that we train the algorithm we pull out multilingual learner, their student models. And then we formed a group of experienced teachers who have extensive experience working with multilingual learners, and then have them to evaluate, to analyze those student models and compare their evaluation with machines evaluation. And one thing you can see very interesting is AI tends to favor mid-range scores, while teachers provide a broader scores spectrum range. So that's also based because of the mechanism or the nature of those kind of machine learning, deep learning stuff. It tends to kind of just kind of equally or normally distributed those scores, right? But as teacher, we actually have some kind of the qualitative study follow up with those teachers and then see, oh, why did you give 2 rather than 3 for this model? The teacher really see that. I know my student, in my classroom, they usually kind of, talk about that in using that gesture and then so translation it into those kind of words. Then when I look at this student model, I kind of incorporate those those insights into my interpretation. So that's something very interesting. So you can see that teacher can usually provide nuances that the AI cannot. So for instance, teacher can it's especially important to highlight that teacher can reason about the context and also capture progressions or not just labels, not just see that this is my student, this model is scored as 2 or as 3. The teacher can really see that, I know he's lost the kind of, the model, he's lost the kind of the artifact, it was like that, and then this one is like that, the teacher can really bring a lot of kind of those background information into the interpretation. So I want to show you there is because I want to kind of, I think AI can do some work, but only with, it's important to emphasize teachers, instructors' role in the process, which AI cannot do. And then the other part is, in my work, I'm showing you here is about trainer's effect. So I was the person who trained those AI algorithms, and I have to choose the which kind of the resonate, the model that I have to use. For instance, I use resonate 18 rather than resonate, a lot of kind of other kind of models. Why I didn't make the decision? Why am I make the decision? Why I am the person, who can make the decision? There was a lot of kind of reflections, and I made a lot of kind of decision just based upon the model's performance, whether that is true or whether that is meaningful for educational purposes. So I did a lot of kind of reflection when I kind of did that work, and I realized that my interpretation is very different from people who have computer science background. So when I work with them, we usually so the same data, the same approach, we usually have very different result, performance. Very interesting because they choose different approach to a model to train. They decided to use 8-4 the kind of the training, the classification process rather than my 10-4, the processes. So a lot of kind of decision-making process embedded in the training process, and then I realized, human, even people often kind of say that AI is a kind of relatively neutral or subjective processes, but it's actually very objective because of the human who involved in the process. And then so I did this study. We did this study together with my collaborator. So we tried to see whether so this trainer has some kind of effect on the training processes. So what we did is it's very hard to, it's a little bit hard to say. So we have some this is use generative AI, the API to do the project, and then we have some kind of CS computer science led feedback prompts. We have some people whose background are computer science, and then they design the prompts. And then we also have some people who are educational background, who work with the CS people kind of together to co-design the prompts. And then what we found is very interesting, and in the middle you can see that is the CS lab feedback. And then on the very right side is the CS and education, kind of the collaborative feedback. So if you kind of dive into the detail, you can see that the CS-led feedback really focuses on efficiency and optimization. So for instance, well done, think again, not quite right, very kind of straightforward, not constructive, not tell it where is it not quite right, and how it is well done. So there is nothing kind of very constructive information inside. And then on the right side, you can see that the CS and education person work together to choose the appropriate core idea to interpret the evidence of data would be necessary in your reasoning process. You can see very explicit, this type of prompts. So we identified we have these 3 different approaches, and the training result is very different. So this is actually one thing that I'm sharing 2 major reflections. One thing is the algorithmic kind of the limits matter. So even with very careful tuning, fine-tune, so AI systems still struggle with nuance, uncertainty, and open-ended reasonings or constructive reasonings, the responses. So it works to some extent, but it's important to realize it's still not working in a lot of aspects that a human can contribute, it cannot. And also human insights really matter in this process. The quality of a AI model is shaped by the people who train it, and also what they notice, what they value, and how they interpret. So especially if you are using some kind of the engineering prompting, the generative AI, the prompts become very essential for your training process. And then so whether you have the knowledge to kind of prompt, identify the area you want to improve, where you have the knowledge to judge the output, the quality, the area that you think it kind of can be kind of better. So it's important. It's professional. It's not just say that do it better. Well done. This is not that way. So I'm kind of here are the two things that really made me think about. So if AI struggles with interpretation, so what else it might meaningfully support? And this actually was the time that ChatGPT released, so so those generative AI tools become a really kind of popular tool. And then I started kind of exploring this work about the co-designing three-dimensional assessment for teachers and students. For those of you who are not in science education field, three-dimensional assessment, three-dimensional learning is a new version of science education. So we really want our students to engage in real-world phenomena or solve complex problems by integrating disciplinary ideas, science and engineering practices, and also cross-learning concepts together. So to think like scientists, do like scientists, and kind of know like scientists, integrate these three dimensions together to engage in real-world learning processes. And then, so the way that I talk about three-dimensional assessment is really standard-aligned three-dimensional assessment that can be used formatively or in classroom as really kind of as real classroom learning activity for students to engage in. So this is the kind of the platform that I'm developing now, and I will talk about it later. And then this is the process I use to design the three-dimensional assessment. We call it evidence-centered design, next generation science assessment project. I was part of the project for several years. And then so one big difference between this process and typical assessment design process is this process really opens up the middle. So you can see, typically we have step one, you have the learning goal, and then you directly design your assessment task. But for this one, we open it up, and then so step by step, how you can make sure the assessment, the activity you design can really measure the construct that you want it to measure. Does it make sense? So I can give you one example that may be helpful for you to understand the way of how this type of assessment look like. We already have a kind of scenario. For instance, this one is shown has 3 dishes of water at room temperature. This is a kind of a scenario, and then we have prompts there. So we ask the student to construct a model to explain what is happening to the water particles and the red dye particles in each dish. This is the kind of the video we provide for them to scale, to engage in the activity. It's a very kind of brief video, but it's very kind of easy. You can tell the difference. Okay, that's the video, I think, yeah. So after student, technology. So after student watch this video, we ask them to construct a model to explain the difference between the 3 dishes, right? And then, so this is one thing. Then after that, they also describe, the second part is how your model show the changes in motion of the dye in the 3 dishes. And then, so from this task actually is measuring one part of this performance expectation in the standard. So it's about to develop a model to predict and describe changes in particle motion, temperature, and state of a pure substance when thermal energy is added or removed. So I'm showing you how this activity is following the evidence-centered design each step and then really measure part of this performance expectation in the next generation science standards. And then for this particular activity is focusing on this learning performance. Students should develop a model explain how particle motion change when thermal energy is added or removed in each state of matter. And then, so we also kind of have the evidence designed throughout our process, the design process. If your students, achieve the goal of this learning performance, their model should have this type of evidence. That as an instructor, you can expect to see this type of evidence in their model. So we have model element, model kind of the relationship among those elements and also correspondence about how you use those elements and relationships together to explain the phenomena that you just observed. So then from there we have some kind of essential task feature. If you want to design assessment, then your task should have this type of feature. But as teacher, you may also have your option to change some feature, to change the phenomena, or to change some kind of objects in your task to make it more aligned with your student. So this is the one consideration for including all students. So what I'm showing you here is so this is a kind of one of the assessment tasks we designed, and then for this the work that I'm doing, I want AI could collaborate with me to design this type of assessment, follow the evidence-centered design approach. So a lot of kind of time. So the one that I just showed you, the assessment, it was pre-designed, and most of the assessment task was pre-designed. So if you use some assessment or learning activities in your classroom, but your student may be different from my student. Every classroom is different, right? So can those pre-designed assessments always be directly used in classroom? Apparently, the answer is no, right? And so a lot of teachers said, I like those assessments, but my students, they do not have this experience. I have to change, I have to adapt it. And then so that made me really think about, how can we support diverse student learning? So if we want to support diverse student learning, we really require us to design some assessment or learning activities that are accessible or adaptive to those kind of the student, their background, or the classroom context. So this is the work. So since starting from my dissertation study, and then so which led to my current the postdoc fellowship. So I have been exploring how can generative AI and human collaborate together to design assessment that accommodate diverse student linguistic, cultural, and cognitive needs. So it's important to define what do we mean by AI. We already talked a lot about AI, but I think the way how you define AI really kind of impact the work that you affect the work, how you treat it in your research work. So in my work, I really kind of use relational epistemology from the socio-material perspective to define AI. So which means in my work, I conceptualize AI based upon human technology, this interaction, rather than just treating AI as a standalone computational system. So in this case, AI is defined by my context, in my context. So those relationships between humans and the computational artifact during the specific interaction, for instance, the designing the activities, how I interact with, how the human expert interact with the generative AI. So it's a relational kind of perspective. So I also use distributed cognition theory to understand the interdisciplinary human expert, their intelligence and how their intelligence interact with AI. So for for distributed cognition theory, we usually argue that so cognitive processes are not only kind of confined to an individual or distributed across people. For instance, if I have my clicker here, so I may kind of interact with me to affect my cognitive processes. And in my work, I actually expand these actional cognitive resources from the traditional static or traditional digital tool that may not have the intelligence like generative AI to generative AI, which have really kind of a generative feature. So which is the kind of the unique feature of generative AI. It can use natural language to allow you to interact with it. And also I expand the external cognitive resources from the sometimes only your internal cognitive processes with my interdisciplinary human expert panel to draw on their cognitive resources together. So this is the model that I proposed in my work called kind of hybrid human AI collaboration model. On the collaborative model, on the left side is the human model. So use self-regulated learning to identify three phases about when human and generative AI interact with each other. What kind of across these three phases, what kind of activity that human may play an essential role, what kind of activity that AI may kind of play some role in the process. This is the right side. I can open it up if you have any questions, given the time constraints, yeah. So this is the training environment. I use OpenAI's API, specifically GPT-4 Turbo Preview, this pre-trained model to do the kind of the process, to do my experiment. If you ask me why is GPT-4 Turbo Preview, so I think that's the question I got kind of many times from different people. So I can share with you. This is a very hard question that I tried to kind of went through when I did this work, because AI model just rapidly changing, developing, and then I kept chasing those operations when I did my work. And then so eventually I stopped with kind of focusing on my educational problems rather than AI models. So I think I don't care about which AI model that I may use. I only as long as the model can solve my problem, then that's it. So so I know this is maybe if you are doing some AI work, maybe that's something that you are also kind of wondering. We are not computer science people comparing the performance among different kind of models. This is not our work. Our work is whether this model can solve your problem. So that's why I stopped kind of the Turbo Preview, because that's the model that I can access at that time, and it worked very well. So I did the work with generative AI together. After I generated those interim products using the evidence-centered design approach, I formed an interdisciplinary expert panel. Those panels have different backgrounds. So some of them are assessment, content expert, or some of them language kind of active expert, and some of them engagement expert, and also some practitioners, for instance, school leaders and also the teacher expert. They all provide different their feedback to those kind of design products. And I collected their feedback and go back to analyze their feedback, reincorporate their feedback into the training process to interactively improve the process. So this is one group of feedback that I received from my panel. So you can, in this height map, you can see that there are some kind of area I received some consistent feedback. For instance, the language reading level, culture inclusive about the phenomena. Most of the kind of the experts feel like the language reading level is a little bit kind of advanced for third grade student. And then but there are also some discrepant feedback in terms of engagement, interest about the phenomena, visual representation. For instance, some kind of the expert feel like this kind of the phenomena in the assessment task is very compelling to a student, to my student. But some of them say that no, it's not compelling at all. So those are some discrepant feedback. I'm showing you here because that will lead to my later kind of reflection. So this is the kind of specific example that I present here from the language expert. For instance, one language expert said that I can see that in your designed artifact products, So for instance, equipped alongside a brief, and also those terms are too advanced for third grade students. And the teacher expert shared a very similar feedback with me. And then, so this is easy to resolve. Then I just go back to re-examine those kind of language level and to adjust the kind of the language in my kind of training process, you draw on some kind of language standards and levels. That's one. This is a culture inclusive one. So this is the kind of, after I do this revision, these slides show you the two different versions of assessment task designed by generative AI and human together. So it's actually not bad. And for this one, it's about the argumentation assessment task. So students should engage in argumentation from evidence to support a claim about which algorithm can survive well, less well, or not well, not at all in a specific habit based upon their characteristics and needs. So this is one kind of the learning goal that I try to measure using the assessment that I designed. So compare these two rounds of expert feedback. So these scatter plot really show the difference between these two rounds. So the red dots show the feedback from the second round. The blue dots show the feedback from the first round. From the left side to the right side is from the lower score to the kind of higher score. So you can see that from the two rounds there was a noticeable improvement for most of the criteria. So among almost all the kind of expert group. So which give us some kind of insight is when you train appropriately or work with it appropriately, it has the potential to really kind of act as human partner to design these type of tasks. However, there are still rooms for improvement. For instance, those three ones that I circled here. So it's about language appropriateness, cultural sensitivity, inclusion. So they are still not working well. So then after I did my dissertation work, so some kind of reflections really was in my mind. One thing is about the operator biases that also kind of correspond to the trainer kind of effect, right? So I collect all of those kind of the experts' feedback and then go back to analyze them using thematic analysis and then try to identify the common themes and then make a decision about this consistent feedback. It's very easy to make decision about those consistent feedback, but it's very hard to make some kind of the decision about the discrepant feedback. Which way should I go? Which one should I kind of take? So I was the person, although I discussed with some kind of my advisors kind of during the process, but I still need to make the decision. But I was the person made the decision, but why me? As well, also I asked this question, right? So, but I shared with you that is because it's not only me, it's not only this kind of the assessment design process. If you are using any generative AI tool, their kind of the generation process may also experience the similar kind of the concerns. And I reflected my background, chemistry background, English language learner, which may really affect my ability to judge the product developed in life sciences domain. That actually show presented in my result. All the kind of the experts, their feedback on those kind of assessment designed for the physical science domain performed, scored higher compared to the assessment in life sciences field. So I reflect because I'm very confident about providing feedback, providing kind of judgment about those physical science, those artifacts. But when it comes to life sciences, I'm not very sure. So that impact the design process. And as English language learner, I may lack of the ability to judge the language appropriateness. That's why that domain still kind of remain under kind of improved. So that's one thing. The other part is so it lack of student input because it was really hard to get RD at that time if you involve student about AI research. Until today, it's still. So then, but if you really want want to see the effect or the validity of your assessment task, you have to get their students, their voices into this process to really understand whether it works or not. And also beyond the development, when I did a lot of kind of interview with the teachers who participated in my study, a lot of them mention about their school does not allow them to use AI, or some of them ask them to use AI, but they don't know how to start with. And also their infrastructure, their system is not ready for incorporating these kind of AI tools, and they ask me a lot of kind of questions about. I realize there's more than just design, but also there's a sustainable kind of problem that may show up if we kind of do AI-related work. And then that leads me to the third stage, which I am doing now about integrating AI design through community engagement approach. So really kind of bringing all those kind of different voices from the State Department of Education, from those local education agencies, from the school district, those teachers, superintendents, let's kind of work together to really think about how we can, if AI is something that we should do something, then what is the way? What is the roadmap? That's the recent project that we got from Microsoft to support, especially the area where I'm from, the Eastern Washington area, where it's very rural, and that we try to build this kind of roadmap for the school district there. So back to the first kind of the biases about the operator biases. So I was really kind of worried about why I made the decision, why I choose which direction I should go. So that's lead to my current postdoc fellowship project is about I proposed a multi-agent system, AI system, to play a different role as like the one that I had in my interdisciplinary panel, to create a virtual space for them to directly interact with each other without my kind of operation in the process. But still, it's in the process of building, and this project is not only kind of leveraging multi-agent system, but also leveraging also using RAG, the retrieval RAG augmented generation, this kind of the framework to make sure it's domain specific, domain specialized, not only kind of a generative AI tool. So the other part is, as I mentioned, the sustainable pipeline. So if you, once you have the AI tool or the AI platform, and once you kind of start kind of talking to the school district, to the teachers, to the leaders, they curious about how I should kind of start, whether I should start. So this is another the work that I just shared with you, the new Microsoft AI project. We are working with school partnership from the Eastern Washington, Northern Idaho, and also the Eastern Oregon, together to build this kind of AI diffusion in the K-12 classroom. So the AI literacy part is also important when you talk to teachers, because if you want them to use AI tool, then they have to have some kind of fundamental AI knowledge before they can really know how to responsibly and also effectively use this AI tool. So those are kind of part of the workshops that we have been providing nationally and also the statewide. So the last part that I want to share is the strong evidence really matters. Whether your work, whether your design product really kind of can impact student learning or teachers teaching, we have to have some empirical evidence. And this is the work that we are collaborating with AIR, the American Institute for Research, to conduct a randomized control trial design to really use a large scale validation, scalability study to test the multi-site impact on the adaptive AI system that I just showed you. So I want to kind of share with you one thing that David and I David invited me to be one part of the team. We, the great team that we presented something at ARA 2025. We talk about AI and education justice because we feel like, it's an important kind of topic that to raise in education community about this critical lens. You cannot just directly bring AI into your classroom without any kind of consideration. So one thing I did share is I think optimization without human expert could reproduce some inequality. So if you just use AI but without human expert input, so you feel like that you kind of speed it up, you kind of optimize it, but actually you are kind of reproducing some AI, some inequality. And then so a lot of kind of people are developing AI tools, but who gets to define what a good AI product look like? Who gets to define? And also whose expertise actually shapes what gets optimized? So those are the questions I really, so I'm still thinking about. And those human in the loop kind of, pipeline could help us, but as I shared with Nancy and Stacy this morning, I actually changed a little bit from human in the loop to the human center. Human should not be in the loop, AI should be in the loop. So human should always be the center in education studies. So a lot of time, if you use generative AI tools, at first glance, you look at the output, it looks really kind of good, right? But good for whom? So this is something I want to share. And also, as we are kind of moving toward handling those kind of AI problems, especially for someone who are building these AI tools, systems. So 2 questions I have been really thinking about, and if you are doing this similar research work, I also kind of encourage you to think about is, are we building these systems that learn from teachers, or are we just building these systems that teachers must learn to use? So work with them together using co-design approach to really kind of design those accessible, responsive system, AI tool, or you just kind of develop something, say that, oh, here you go, then use it. And then are we treating optimization as something AI does to education, or something we could do together grounded in justice? I think that's something AI can always help us to do more, but only if we decide what matters first and who gets to decide. Hi, so I'm going to stop here, and then so happy to take any questions.
Yeah. I think this will work. Maybe we'll try. Yeah, thank you, Ting, so much for that. And I'll open it up. We have time for some questions or conversation if anybody has any things. Yeah, Dave. I'm coming.
Thanks, TingTing, for that wonderful presentation. My question is about this human AI collaboration piece. How do you see the human experts responding to what's already been generated by AI? Some of the work I've been doing, one of the concerns is that humans tend to anchor to whatever AI has already produced in terms of their evaluations, and so if for instance with the scoring of student work, if the AI produces a score of a 2, humans just kind of tend to gravitate to the 2 again, so I don't know what your thoughts are on that and how to break that kind of anchoring effect. So just would love to hear your thoughts on that.
Thank you so much for the question. I think that's very common based upon my experience, So that's 2 things I have been thinking about that, So one thing is about about AI literacy. So they may not have the knowledge about how AI works and why, so they just feel like, AI has the magic power and then just to kind of accept it. Because of they have no have very limited understanding about the mechanism of AI, and once you present them some kind of, the mechanism of how AI works, it's just a statistical modeling. There is no comprehension, there is no understanding, there is no reasoning. It's just kind of the probabilities, right? And then they started kind of, showing a little bit of critical thinking, critical judgment. That's one. The other part is it's also based upon their professional knowledge. So their professional knowledge is, especially for the teachers, the science teacher, the elementary teachers that I work with, a lot of them do not have science background. So whenever the AI produces something, they feel, oh, it's great, it's even better than what I did. But why they think about it in that way? Because they don't know what does good mean for science learning. So those are the reasons I think about, and then, so that's why I think education, we still should still strengthen their professional knowledge, but at the meanwhile, we also should provide some fundamental AI knowledge to them. So if we want them to work with AI efficiently, and responsibly. So that's from the kind of the education perspective. But if you from the research perspective, that's a little bit different. So research perspective, then we have to ask them, why? Follow up, a lot of kind of questions that what I did. So if they said this is great, I want to know more, I like it, and then so which part do you like? And why you think it's good, so follow up and then keep kind of pushing them to think more, and then so you're gonna help them to figure out that there is something, so maybe not good or not. I'll respond to the question.
Thanks for that talk. That was really interesting. Early on, you talked about a goal of yours and kind of why you started using AI, which was this idea that you really wanted to be able to scale meaningful interventions very broadly.
Yeah.
And as you've done more and more work, when you're thinking about really having co-development and co-design with teachers and kind of that human intervention, there does seem to be some limitations in thinking about that scaling. I wonder, based on your work now and where you've come, kind of how you think about the potential of AI as a scaling tool and where you see the boundaries of that.
Great. Great question. I think so first, I want to say that I'm still in the exploration process, but the reason I want to kind of share with you all with this kind of insight or experience I have is, I think it's important to raise these concerns or problems that I observed, have been observing. But on the other side, I also see the potential of AI could scale some kind of these high quality, meaningful education experiences. The reason why is, so even AI, so for instance, let's go back to the kind of the, let's take the assessment as an example, right? So when I was in the assessment project, so that was like a 3-year project with collaborations among 3 institutions, 2 million, but we were only able to design 20 tasks. Because of the process is very complicated, and it requires a lot kind of expert input into the evaluation process, several rounds into the review, right? But with this kind of the generative AI, it's really achieved the goal of it can, to produce some kind of the high quality assessment task in a short time, in a short time. So that's one thing, right? I can see, it could, but it needs more work. It needs more careful work. That's why I'm doing this now, So if we can design the adaptive AI system that I'm developing now is really following the evidence-centered design process, but with those humans inside, when we co-develop those kind of the system together. But co-design is a really big term. Co-design is really big term. So everyone can talk about co-design or co-develop. So then, but what does it mean? So at the kind of the initial, the system purpose define stage, then move to the kind of, the interface, user interface stage, and then also the core function of the system. Though there is a lot kind of different kind of things that we have to consider, but it will take, it takes very long time, but once you really figure it out and also really done this part of the work in a robust way, the AI system could produce some really high quality assessment tasks. That's the way that I can see the potential. I'm still kind of, hold a very, I'm holding a cautious, but promising kind of the perspective on AI using education at this time point. I may change. Yeah, I may change.
I'm going to usurp the last question because I want to build on what you're saying, and I want to think about assessment. And I always think about it because I'm going to point to Becca here, who was in a class. Yeah, I'm talking. Do you remember the discussion we had in our class last year about would you like to be assessed by an AI? So we had this cool conversation in our class that I taught about like we can read papers written by researchers who use it to assess students' understanding of fill in the blank, whatever. I've yet to see a study where students are asked their opinions about that, whether they want to be or consent to be assessed by an AI. So we had a cool conversation about that in our class. So I would love to hear your thoughts since you brought it up at the end of your talk. How would you do that? Like, how would you bring students into the conversation about designing an AI for assessing their understanding of something? And then what do you think our field needs to think about if we're going to involve students in the process?
Yeah, that's a really great and challenging question. The reason why is until today, I shared with David a little bit, because of the student, their very unique position, I'm still very cautious of bringing them into my research work. So all of my research work really kind of, try to bring teachers and also the other kind of the stakeholders in the education system. But I think it's important to realize that student is the last voice. I know they're important. They are important. But when it kind of, comes to the AI-related research, I think students should be the last one to be looped in the conversation. So the reason why is I really want to make sure the system and the research design is very ready from the teacher, from the adult, their perspective, for them to chime in. So that's one. And then so actually I started a little bit, the lab cognitive interview with student, middle school student. They are very excited. they feel like this is very new technology. They want to know more. They ask me a lot of kind of questions about how does it work, why you can build it, and how it kind of really kind of can assess me. What I want it to be in this way and in that way. They are excited. I want to see that. I think students are really kind of well ready to kind of accept this new technology. But just when we design this educational purpose tool, we have to think about it's theory driven, it's empirical kind of the grounded, right? So those are our considerations. But from student perspective, they, at least based upon my experience, they like it and they want to know more.
Yeah. All right. Let's